Welcome to our video on transformations.
Hi, I'm Mo.
I'm Julie.
And I'm Neha.
Today we're going to be teaching you all about horizontal and vertical translations,
Vertical stretches and compressions.
And horizontal stretches and compressions.
Some basic prerequisites that you're going to need are fluency with vertex and standard form,
The ability to identify axes, coordinate planes, and points on a graph.
And basic knowledge of parent graphs.
At the end of this video, students will understand how transformations to an equation affect the graph. First, I'm going to talk about the amazing things that are translations. Hopefully, we are all familiar with vertex form. Y equals the quantity x minus h squared plus k. In vertex form, k is a constant, and the coordinates hk are the vertex of the parabola. Let's take a look at the parent graph of a parabola. But what if we had something that might be just a little more difficult to graph? For example, what if we had y equals x squared plus 1?
Mo, how would we graph that?
That's an awesome question, Julie. Let's learn how to do it together.
Yay!
Looking at the table of values for y equals x squared and y equals x squared plus 1, what do you notice, Jules?
Oh my goodness, the y values all go up by 1.
Exactly! This is called a vertical translation. As you can see, the graph goes up by 1 unit because you're adding 1 to all the y values. And guess what would happen if you had the equation y equals x squared minus 1? You guessed it, the entire parent graph would move down 1 unit. Now let's try something called horizontal translations. Now let's look at the graph and the table of values for both of the functions x squared and x minus 1 squared. Looking at the table of values, what do we notice? Well, one of the coordinate points that we clearly see is -2 and y value of 4. But if we look at the table of values for the transformed equation, we see that the value 4 actually goes with the x coordinate -1. Now if we look at our graph, we can see what actually happens here. The entire graph gets shifted over 1 unit to the right when 1 is subtracted inside the parentheses. Now let's compare the graphs of y equals x squared and y equals x plus 1 squared. The point 0, 0, as shown here, becomes the point -1, 0 on the translated graph. Here, the entire parent graph is shifted 1 unit over to the left.
Now, let's talk about vertical stretches and compressions. Let's look at this graph of a parabola. But what if, instead of a regular curve, we wanted to make it skinnier? What we would do is called a vertical stretch. As you can see, the parent graph becomes tighter together. And if you look at the points, like the point 1, 1, on this transformed graph, it becomes 1, 2. And the point 2, 4 becomes 2, 8. Do you notice the pattern? The y gets multiplied by 2. So to vertically stretch a function, you have to multiply the entire side of an equation by a factor. So on the top parent equation, it's y equals x squared. But down below, it's y equals 2x squared. Because all of the points on this graph, the y's get multiplied by 2. So a vertical stretch is when you multiply the entire side of an equation by a factor greater than 1. Sometimes, though, instead of the parent graph getting smaller with a stretch, you want the parent graph to get wider. This is called a compression. Now, instead of multiplying the parent graph by a factor greater than 1, you multiply by a fraction. So to get from 4 to 2, what fraction do you multiply by? You multiply by a half. Now all of your y's are divided by 2. So the definition of a vertical compression is when a function is multiplied by a factor between 0 and 1.
The last thing that we're going to cover are horizontal stretches and compressions.
Graphically, a vertical stretch looks very similar to a horizontal compression, and a horizontal stretch looks similar to a vertical compression.
But Neha, if they look the same, how can we tell the difference?
That's a great question, Mo.
While the vertical transformation acts on the y in the equation, or the entire equation, the horizontal transformation acts on the x. So to horizontally compress the fraction, you have to multiply the x value by a factor that's greater than 1, and the y values will all be multiplied by the square of that factor, in this case 4, and the graph is compressed this way.
But what if the factor's a fraction? Is that a horizontal stretch?
If the value of the factor is between 0 and 1, that does create a horizontal stretch. For example, in this equation, y equals the quantity 1/2 x squared. The y values are all divided by 4, and the graph is horizontally stretched this way.
Hopefully, from this video, you learned all about the various aspects of transformations. We talked to you today mostly about quadratics, but understand that transformations occur in all parent graphs and to all functions. A horizontal translation will turn from f of x into f of x minus h. A vertical translation will turn f of x into f of x plus k. In this video, we also talked about horizontal and vertical stretches and compression. In a horizontal stretch or compression, f of x turns into f of a of x, where a is your factor. In vertical stretches and compressions, f of x gets transformed into a times f of x.